You know, Ziggy, you know what really bothers me nowadays?
What, David? What bothers you, dude?
The fact that people don't know about bond strength.
I feel that, dude. Not for real.
Yeah. But like, you know, it might be a good idea.
What?
If we made a video that taught people about bond strength.
We should do that, dude. We could use our friends, Mel
And Alicia. Good. Yes.
All right,
Let's make this video.
let's do it.
Today we're going to focus on covalent bonding. Now, what is covalent bonding? Covalent bonding is when two atoms share electrons between themselves in an effort to reach a full octet. Now, by themselves, atoms can have anywhere from 1 to 8 electrons in their outer shell, but they're only happy when they have a full octet, which means they have 8 electrons in their outer shell. But the only atoms that exist like this in their uncharged, alone state is the noble gases. Now, all atoms want to be happy, but if they can't achieve this individually, how do they do this? Well, it's really simple actually. They form bonds. Atoms can share electrons between each other in an effort to reach a full octet, even though they couldn't individually. So take this case, where each atom has 7 electrons on its own in its outer shell. So what they're able to do is come together to form a single molecule, and they share 1 electron each, forming the presence of 8 electrons. Now, when 2 atoms are sharing 2 or more electrons, like in this case, we have covalent bonding. There's a lot of variation in covalent bonding. For example, the number of bonds. Now, covalent bonds can exist as single, double, and triple bonds. In a single bond, 2 electrons are shared between the 2 atoms. In a double bond, 4 are shared, and in a triple bond, 6 are shared. And as a result of the increasing number of electrons that are being shared, the strength also increases of the bond. So a single bond is the weakest, and the triple bond is the strongest.
Hi, Alicia. Well, as you just said, the first thing you need to make a covalent bond is 2 atoms, but I can't seem to find my two. There he is. Ziggy, my atom in crime. There he is. Well, Alicia, you just said that the first thing you need is 2 atoms, right here. And you said that covalent bonds can either be a single, double, or triple bond. Well, as you have bonds, as they increase in number from a single to double, the atoms get closer together because the electrons are pulling closer. So you can think of it as this. A single bond is just a handshake. But when you get to a double bond, you get a little more intimate with the other atom. Finally, you can't break this triple bond. We're so close.
The second factor that we have that affects covalent bonding is the atomic radius. Now, the atomic radius refers to the size of an atom and is found in a downward and leftward trend across the periodic table. And as you get to a larger radius, you have a weaker bond. So smaller atomic radius yields a stronger bond. This occurs because the atoms are closer together when their atomic radii is smaller, and that results in a tighter bond, a stronger bond, and a bond that's much harder to break apart.
Hey Alicia, so as you just said, as atomic radius decreases, the bond strength is going to increase. So we can see this between me and my atom in crime, Ziggy here. So let's assume that we're diatomic molecules, so H2, O2, that sort. And right now we're going to be iodine. So iodine is a larger molecule of the diatomic halogens. And so the bond between Ziggy and I, it's going to be pretty weak. But let's say we go to bromine, which is a little smaller. We're going to get closer, and our bond strength is going to get increased. Now let's say we're chlorine. We're going to get even closer together, and we can just start to feel a bond forming. And for fluorine, which is the smallest of the halogens, we are very close. And you cannot break this bro bond. Back to you, Alicia.
And the final factor we have in covalent bonding is electronegativity. Now, electronegativity is how much the atom wants the electron. Now, this implies that different atoms pull the electron with different strengths in a bond. And this can be seen in an upward and rightward trend across the periodic table, with atoms down here being the least electronegative, and atoms up here being the most electronegative. So, this difference in electronegativity can create a different strength in the bond. So atoms that have a high electronegativity can bond with an atom that has very low electronegativity to create a stronger bond. But if 2 atoms with similar electronegativity form a covalent bond, the bond is not very strong.
Hey Alicia, so for this demonstration on electronegativity, my atom in crime, Ziggy, and I are going to need an assistant. So we're bringing in Mel. who in this will be functioning as an electron. Give a round of applause for electron metal. So, electronegativity. Let's assume that Ziggy and I are both fluorine atoms. Now, fluorine has the highest electronegativity on the periodic table. So right now, Mel being an electron, since she's in between two of the same atom, she's going to be about in the middle. She's not going to veer to anyone's side. But let's assume that Ziggy, instead of being fluorine, is now a carbon atom, which is less electronegative than my fluorine atom. So Mel, whoa! Did you see that? She went towards the atom that had a higher electronegativity compared to Ziggy's. So as the difference in electronegativity increases, the electron will go towards the more electronegative atom more. Now you may be wondering how this affects bond strength. Well, as Mel, the electron, came over here, we see that I am now a more negative zone, while Ziggy is a more positive zone. And this creates polarities, which creates partial charges, and now we start having some ionic action in the bonds, and that's what increases.
But remember, kids, the most important bond of all is the bond of friendship.
Yeah.